Today we're going to be talking about the parts of and translating algebraic expressions. So in particular, we want to be able to understand how can we use math to model real-world scenarios. And algebraic expressions allow us to do that because typically in an algebraic expression, we use a variable of some kind, most commonly an x, to represent this is a placeholder value where you can replace it with whatever number makes sense in your scenario. So if, for example, you were making $10 an hour at your job, you might represent your take-home pay as 10x. And then the x you could replace with however many hours you worked that week. Versus you would pick some other job that makes perhaps maybe some sort of commission type of pay, where maybe you get $15 an hour on top of just a base pay of $100 a week. By commission pay, I really should have said maybe not $15 an hour, but 15 times however many things you sell. So in that case, X would be how much you sell plus a base pay of $100 a week. Again, you can use these expressions to represent whatever scenario it is you want to be working with. So they pop up in every single applied context. So it's really important to understand how they work, what's its anatomy, what are these expressions actually saying. Expressions are different from equations in that equations have an equal sign of some sort such that you can only actually replace that variable with one or a set of values so that the equation is true. So if, for example, I said that 10x was specifically equal to 100, then you would know x has to be 10 because 10 times 10 gives us 100. There's no other value I could plug in for x and make that statement true. And there might be a set of values because if I said x squared is equal to 4, then x might be 2 or negative 2. Great, that's still an equation though because those are the only two values I can plug in and make that equation true. Versus if I just had an x squared by itself, that's an expression I can plug in whatever I want for x squared. So without me yapping for too much longer, go ahead and try out these next two examples. Is that an equation or an expression? Which one is which? So the first one is certainly an expression because there is no equal sign. That is just anything can be plugged in for z and it's still true. Versus the second one is certainly an equation because there is an equal sign. There's only a particular value that I can plug in for x. In future videos, we'll go over how to actually solve equations that look like that, but it is an equation because of that equal sign. There's only a particular value in this case or potentially a set of values that would make that equation true. Let's talk a little bit about the anatomy of an algebraic expression. What I mean is what language are we going to use to talk about the different parts of an algebraic expression? One of the most important parts is the coefficient in the expression. And coefficient is a fancy word for the number that is being multiplied out front of a variable. Technically, it should usually go out front by convention, but like if I wrote y times 5, technically 5 would still be the coefficient because it is the number being multiplied by the variable. But by convention, we try to write that as 5y just to make things less confusing and make it really, really easy to find that coefficient, the number out front. It can also be the number out front of a set of variables all being multiplied together. So in like negative 7abc, negative 7 would be the coefficient for the whole expression. And keep in mind that if you see a variable that's just sort of by itself, it does still have a coefficient. For an x by itself, keep in mind that's secretly being multiplied by a positive 1, so its coefficient is actually 1. For a negative y by itself, keep in mind that's secretly being multiplied by a negative 1, so its coefficient is actually negative 1. So with that in mind, go ahead and try to practice these terms. So try to see in these terms what would be considered the coefficient and what would be considered the variable. So in the first term, 5 is our coefficient, while t would be considered the variable. So the variable traditionally is some sort of letter. Keep in mind it doesn't technically have to be an English letter. You know, you could have something like 5 sigma, where there's this funny little O they have in Greek letters, for example, and 5 would still be considered that coefficient. If you have a negative r by itself, r is your variable, and negative 1 is your coefficient. If you see a g by itself, g is your variable, and 1 is secretly your coefficient. If you see a 1/8 x, variables can be multiplied by fractions. That's totally fine. 1/8 is your coefficient. Negative 2x over 3, there really the entire coefficient is still that whole negative 2 over 3 business. So negative 2/3 would be the entire coefficient. If you see an m over 4, there that would really be 1/4 times m over 4, 1/4 times n times m, tomato, dividing by 4, multiplying by a fourth, it's the same thing. 1/4 would be your coefficient. And on this last one, keep in mind for d squared, the squared part is actually describing that the variable is being multiplied by himself. The 3.08, that would be your coefficient part. Now, coefficients aren't the only parts of the algebraic expression we can talk about. We can also talk about what are the terms and how many terms there are. Terms are going to be separated by some sort of plus or minus sign, and that just differentiates the different types of terms in the expression. If they're being multiplied or divided together, that's considered a single term. So in negative 7 ABC, for example, this was just considered one term because they're all being multiplied together, versus if I had negative 7 plus A plus B plus C, now we're at 4 terms because I have each of them separated. And I could even change one of those addition signs to a minus sign, and that would still be 4 terms as well. The constant is going to be whatever number is kind of just by himself, is the plain number by himself with no variable attached. The coefficient is the number in front of a variable, and a constant, keep in mind, is considered his own coefficient. So even if I see a negative 7 chilling by himself, technically he's being multiplied by some variable to the 0th power. This is kind of how we justify it in mathematics. And anything to the 0 is 1, which is why you don't see it. So there's sort of a secret multiplication by a variable that just can only take on the value of 1. That's kind of the technical math reason why. Or if you just want to remember whatever number is there, that's the coefficient, great. That's a good way to remember it too. So for example, in the expression 3x squared minus 4x plus 7, we've got ourselves 3 terms. One of those terms is 3x squared, the other one's negative 4x, and the other one is 7. The constant is going to be that 7 who is by himself. He is not in front of an x of any kind. For the first term, his coefficient is going to be 3 because he's being multiplied by 3. For the second term, his coefficient is negative 4 because that minus sign is considered attached to the term. It is because the same thing as doing plus negative 4x, so the negative 4 is that entire coefficient. And for the last term, he's his own coefficient, which is 7. Go ahead and pause this video and see if you can complete this practice problem. So for this practice problem, and maybe I should actually zoom this in just a wee bit more if that's a little bit easier to see. So for this practice problem, there are a total of 1, 2, 3, 4 terms. The constant term will be this negative 7 who's hanging out by himself because he has no variables attached. For the first term, his coefficient is actually 1/3 because dividing by 3 and multiplying by 1/3 is the same thing. There's really a 1 in front of that x cubed. For the second term, his coefficient is negative 1/4 because that negative is attached, and dividing by 4 is the same thing as multiplying by 1/4 because, again, if you want to kind of even write in that each of these x's really has a 1 in front, that's what's going on there. And for the third term, 5/2 is the coefficient. For the last term, which is really something I should have written, coefficient of the last term. The last term has a coefficient of negative 7. He's his own coefficient. We can also talk about the opposites of variables. So the opposite is the additive inverse of a variable. So you're basically just changing the sign on whatever it is. Opposite of k is negative k. opposite of negative t is going to be t. But that becomes really important whenever you're solving equations. You want to always be able to identify what would be considered the additive inverse for that variable. So just as a quick check for understanding, go ahead and see if you can identify the opposite of m and the opposite of negative n. The opposite of m would be negative m, and the opposite of negative n would be positive n. So you're, again, just flipping the signs on those, because then if I do m plus negative m, that's going to give me 0. If I do negative n plus n, that will also give me 0.